In order for us to take our next step into trigonometry, we need to introduce the concept of a reference angle. For an angle theta in standard position, the reference angle of theta is the acute geometric angle it makes with the x-axis. Now the word acute here, an acute angle is an angle between 0 and 90 degrees, or 0 and pi over 2 radians. Geometric angle means that we're just going to use the positive measurement and not worry about what direction, whether it's a positive angle or a negative angle. We're just going to call it a positive angle. And so the geometric angle makes with the x-axis. So let's take a look. Let's say we have an angle somewhere over here in the second quadrant. Now if we look at it, the angle that that line makes with the x-axis looks like that. That right there, this is the reference angle. Right, so our angle theta could be over here. This is some angle between 90 and 180 degrees, but the reference angle is this acute angle right here. And so as a practical example, let's just consider what is the reference angle for a 210 degree angle. So first we have to think about 210 degrees to figure out what quadrant it's in. So it's between 180 and 270, so it's going to be in quadrant 3. And so this angle right there is 210 degrees. Everything from here is just a matter of looking at the geometry. Now there are formulas you can memorize for this. I'm not even going to bother writing them down because they're not worth it. Just sort of look at the picture and think about it. If this is a 210 degree angle, how big is this angle right here? Well, we know that it's 180 degrees to this point, and so from here further, you need to go an additional 30 degrees. And so the reference angle for the 210 degree angle is 30 degrees. And we get this by just looking at the geometry. Sometimes you're going to subtract, sometimes you're going to add. It's just looking at the picture and thinking it through. We want to think about the relationship between these reference angles and the unit circle. Now the unit circle is just a circle of radius 1 centered at the origin. So this is a radius 1. And we like thinking about the unit circle for the sine and cosine functions because it makes the denominator equal to 1. So remember that sine of theta is equal to y over r, and cosine theta is equal to x over r. And if we just pick that r to equal 1, then we're going to have that this is equal to y and this is equal to x. And so if we pick some point xy on the unit circle, it creates an angle theta. And we can calculate its values by just looking at the x and y coordinates and not having to worry about that denominator because the denominator is 1. And so here's the set that we have. The question is, what do reference angles do for us? Well, it turns out that we can use reference angles to take the first quadrant and understand all the points on the entire unit circle by just using geometry. So what does that look like? Well, let's say for a moment that we're interested in taking this thing and reflecting it across the y-axis this way. The angle theta ends up being down there. That angle is the same as this angle by reflection. And in fact, this point, if we think about it, if we reflect across the y-axis, the y-coordinate does not change, but the x-coordinate becomes negative. And so that becomes our point, negative x comma y. And now, because this angle here is theta, we can actually look at the angle in standard position. We'll call this thing alpha for a moment. Squeeze that in right there. This angle alpha creates a reference angle theta. And so if we know the reference angle theta, we can actually get sine of alpha and cosine of alpha. Let's just think about that. Sine of alpha. Well, this point right here, sine of alpha is equal to y. The y coordinate, because we reflect it horizontally, is unchanged. So sine of alpha is equal to y. Cosine of alpha, it's the x coordinate, which in this case is negative x. So it's the negative of whatever that one is. And so reference angles allow us to bounce this point from the first quadrant into the second quadrant. And we can do the same thing vertically. We can reflect these things down into the third and fourth quadrants. So if we do a vertical reflection there, we'll see that the reference angle theta goes here and here. Forgive me for them not being very accurate, but this sets us up with this rectangle of points. Down here we have negative x, negative y. Here we have x, negative y. And so by looking at the various angles here, the same reference angle can be used to get all the values for the sine and cosine functions in all the other quadrants by doing this reflection property and just thinking about where the points go.